The cosmos holds secrets that defy our everyday logic. We are about to explore 25 surprising space facts that will fundamentally challenge what you think you know about reality. By the end, your view of the universe will be permanently altered. We will visit a planet where it rains shards of glass and uncover why the emptiest place in space is one of its greatest mysteries. What is the one cosmic fact you find most difficult to believe our own moon is quietly leaving us? Right now, as you watch this, it is drifting away from Earth at a rate of about 3.8 centimeters every single year. That is roughly the same speed your fingernails grow. This gentle retreat is caused by the gravitational tug of war between Earth and the Moon, a dance of tides that slowly transfers energy. The ocean's bulge created by the Moon's gravity actually pulls slightly ahead of the Moon itself, and that forward pull gives the Moon a tiny push, like a parent giving a child on a swing a gentle shove each time they pass. Each push widens the Moon's orbit by those few centimeters. The consequences of this slow-motion departure are profound, though they unfold over timescales almost impossible to grasp. In the distant future, Earth's rotation will slow, making our days longer. The tides we rely on to shape our coastlines and nourish ecosystems will become weaker, mere shadows of their former power. And perhaps most poetically tragic of all, total solar eclipses will one day become impossible. The Moon will appear too small in our sky to completely cover the Sun. That breathtaking moment of daytime darkness where the Sun's corona flares around a perfect black disk will be a phenomenon lost to future civilizations. It is a reminder that even the most constant fixtures in our sky are part of a dynamic, ever-changing cosmic story. While our moon slowly abandons us, another world in our solar system operates on a schedule so bizarre it seems to defy the very laws of time itself. On Venus, a single day lasts longer than an entire year. Let that sink in for a moment. For us, a year is the long journey around the Sun, and a day is just a quick spin. On Venus, this fundamental rhythm is completely inverted. It takes Venus 243 Earth days to complete one rotation on its axis, one agonizingly slow sunrise to sunset. Yet it only takes 225 Earth days for the planet to complete a full orbit around the Sun. If you could stand on its scorching surface, you would celebrate your birthday before you ever saw the Sun rise again. And the strangeness does not stop there. Venus spins in the opposite direction of almost every other planet, a motion called retrograde rotation. On Venus, the Sun would rise in the west and set in the east. The leading theory for this cosmic rebellion is a catastrophe of almost unimaginable scale. Astronomers believe that in the solar system's violent youth, a protoplanet, perhaps as large as Mars, slammed into Venus with such titanic force that it literally knocked the planet upside down, reversing its spin. This ancient cataclysm would have reshaped the entire world, possibly even boiling away any ancient oceans in the process. So while we experience the reliable comfort of 24-hour days and 365-day years, Venus exists in a state of permanent temporal disarray, a world where time itself has been twisted by a forgotten collision, forever reminding us that the familiar order of our own home is a rare and precious cosmic accident. The violent chaos that shaped Venus stands in stark contrast to a far more serene and intoxicating discovery near the heart of our own galaxy. Drifting through the constellation Sagittarius, some 26,000 light-years from Earth, there is a cloud of gas and dust so vast it could spawn millions of stars. And within that cloud, astronomers have found something astonishing, a sprawling reservoir of alcohol. This region, known as Sagittarius B2, contains enough vinyl alcohol to fill billions upon billions of bottles. But this is not the kind of alcohol you would ever want to drink. It is a complex organic molecule, a building block for more complicated chemistry. Its presence is a profound clue. For decades, we wondered if the ingredients for life were unique to Earth, a special recipe cooked up in our planet's primordial oceans. Sagittarius B2 tells a different story. It reveals that the fundamental components for life, the very carbon-based molecules that make up our bodies, are being manufactured in the cold, dark vacuum of space itself. On the surfaces of dust grains floating in these immense nebulae, simple atoms link together, driven by the faint energy of starlight. Over eons, these grains become tiny chemical factories, assembling ever more complex compounds like ethanol, sugar, and even amino acids, the very things that form proteins. When new stars and planets coalesce from clouds like this one, those pre-made organic molecules are baked into the recipe from the very beginning. They hitch a ride on comets and asteroids, seeding young worlds with the raw materials for biology. So every time you look up at the star-rich band of the Milky Way, picture that distant, colorful nebula not just as a nursery for suns, but as a cosmic brewery, quietly distilling the potential for life itself and scattering it across the galaxy. The universe can brew the ingredients for life, but it also forges objects of such staggering extremity they seem like theoretical impossibilities. A neutron star is the corpse of a massive star that died not with a whimper, but in the most violent explosion known to science, a supernova. When a star many times more massive than our Sun exhausts its nuclear fuel, its core collapses under its own immense gravity in a fraction of a second. The force is so unimaginably powerful that it crushes atoms themselves. Electrons are slammed into protons, merging to form neutrons, and the entire core of a giant star is compacted into a sphere only about the size of a city, perhaps 20 kilometers across. This is where the numbers become truly incomprehensible. The density of this material is beyond human scale. A single sugar cube's worth of neutron star matter, if you could somehow bring it to Earth, would weigh over 1 billion tons, as much as an entire mountain. To visualize that, picture taking every car, every building, every person on our entire planet, and compressing all of that mass down into a sphere the size of a small marble. That is the level of compression we are talking about. This insane density gives neutron stars other almost magical properties. They spin at dizzying speeds, some rotating hundreds of times per second. Imagine a ball as massive as our Sun, spinning so fast that its surface moves at a significant fraction of the speed of light. They also possess magnetic fields trillions of times stronger than Earth's, fields so powerful they would strip the information from every credit card on our planet from thousands of light years away. A neutron star is not just a dead star, it is a monument to the most extreme physics the cosmos can muster, a place where matter exists in a state so alien it challenges our very understanding of reality. Yet even the crushing silence of a neutron star is not the final word. We often hear that in the vacuum of space, no one can hear you scream, and this is technically true. Sound, as we know it, requires a medium like air or water to travel. In the near-perfect emptiness between stars, those pressure waves have nothing to push against, so they simply do not exist. But to call space silent is a profound misunderstanding. It is instead a symphony waiting to be translated. Every planet, every star, every swirling galaxy emits a constant torrent of electromagnetic radiation, radio waves, and plasma vibrations. Scientists can take this data, these invisible signals, and transpose them into frequencies our ears can perceive. The result is not sound as nature intended, but a haunting sonification of the cosmos itself. Listen to the roar of Jupiter, a deep, rumbling crackle that sounds like a massive ocean wave mixed with static from an old radio. That is the sound of its intense magnetic field interacting with charged particles from its volcanic moon, Io. Or consider the cosmic microwave background radiation, the faint afterglow of the Big Bang. When shifted into audio, it becomes a deep, uniform hiss, the literal echo of creation itself, a whisper from the universe's first moments that has been traveling for over 13 billion years to reach us. Perhaps most eerie are the pulses from rotating neutron stars, which convert into a rhythmic, metallic ticking, like a cosmic lighthouse beacon cutting through a silent sea. So while you would not hear an explosion in space, to say it is silent is like calling a rainbow colorless simply because you are blind to its light. The universe is constantly broadcasting, singing in a spectrum of energy we are only just learning to hear, revealing a hidden layer of reality that is both beautiful and profoundly strange. But the cosmos is not just a place of invisible symphonies, it is also a sculptor of monuments on a scale that dwarfs anything on our world. On the rust-colored plains of Mars, there stands a mountain so vast it redefines our concept of what a mountain can be. This is Olympus Mons, the largest volcano in the entire solar system. To understand its size, you must first erase your mental image of Earth's jagged, towering peaks. Olympus Mons is a shield volcano, built not by violent explosions but by countless gentle eruptions of fluid lava that spread out in all directions over millions of years. The result is not a steep pyramid but a sprawling, gently sloping giant. Its summit soars 21.9 kilometers above the Martian surface. That is nearly 2.5 times the height of Mount Everest from base to peak. But its true majesty is in its footprint. The base of Olympus Mons covers an area roughly the size of the entire state of Arizona. If you were standing on its outer edge, the summit would be over the horizon, hidden by the curvature of the planet itself. The volcano's caldera, the collapsed crater at its top, is a complex of 6 overlapping pits so large you could fit a small city inside. Why did Mars allow such a colossal structure to form, while Earth did not? The secret lies in plate tectonics. On Earth, the crust is broken into moving plates. A volcanic hotspot will punch through the crust, but as the plate slides over it, it creates a chain of volcanoes like the Hawaiian Islands, rather than a single massive one. Mars, however, has a static, single-plate crust. For billions of years, a single plume of hot material from the planet's mantle rose to the exact same spot, relentlessly pouring out lava, layer upon layer, with nothing to move it elsewhere. It grew, undisturbed, into the solar system's most titanic landmark, a frozen testament to a world where geological forces worked with a singular, patient focus we will never see on our dynamic, shifting Earth. While Mars built a mountain of unimaginable scale, the universe has forged worlds from materials we would consider impossibly precious. Deep in the constellation of Cancer, orbiting a star 41 light-years away, there exists a planet that might be the ultimate cosmic jewel. Designated 55 Cancri, this world is classified as a super-Earth, but it bears no resemblance to our own. It is a searing hot, carbon-rich sphere that astronomers believe could be composed largely of diamond. How does such a fantastical world come to be? The story begins with its star, which is unusually rich in carbon compared to our oxygen-rich sun. When the planetary system formed from a swirling disk of gas and dust, that extra carbon became baked into the recipe of its orbiting worlds. 55 Cancri is thought to be a carbon planet, a world where carbon, not silicon like in Earth's crust, is the dominant rocky element. Under the immense pressures and scorching temperatures found deep within this planet, carbon would be forced into its most stable, crystalline form. Imagine the entire interior of a planet, a core larger than Earth's, slowly crystallizing into a solid mass of diamond over billions of years. The surface, however, would be nothing like a glittering jewelry store. It is likely a hellish landscape, tidally locked with one face perpetually facing its star, where temperatures soar above 2,000 degrees Celsius. The rock you would stand on, if you could survive, might be a dark graphite crust with unimaginable fortunes of diamond lurking just beneath. This discovery shatters our assumptions about what planets are made of. We grew up learning about rocky worlds like Earth and Mars and gas giants like Jupiter. but 55 Cancri reveals a stunning new category, proving that the ingredients available in a stellar nursery can cook up planets of staggering variety. If a world of diamond can exist, what other impossible substances might be lurking out there in the darkness, waiting to be found? Diamonds forged in the crushing heat of a distant world are a testament to the universe's strange chemistry, but our own star holds a mystery that has baffled scientists for generations. The surface of the Sun, the photosphere we see as a bright disk, is a relatively cool 5,500 degrees Celsius. Yet just above it, in the wispy outer atmosphere called the corona, temperatures skyrocket to over 1 million degrees. This is the coronal heating problem, a paradox that defies basic intuition. It is as if you walked away from a campfire and instead of the air getting cooler, it suddenly became scalding hot, thousands of times hotter than the flames themselves. For decades, this has been one of solar physics' greatest puzzles. How can the Sun's atmosphere be so staggeringly hotter than its surface? The leading theory points to the Sun's tangled, dynamic magnetic field. Imagine the Sun's surface is like a pot of boiling water, with magnetic field lines rising and falling like strands of spaghetti. These lines can become twisted, stretched, and knotted. When they snap and reconnect in a process called magnetic reconnection, they release colossal amounts of energy in a fraction of a second. It is like stretching a rubber band until it breaks. The sudden snap releases stored energy. This process is thought to create countless tiny explosions across the solar surface, events called nanoflares. Each one is minuscule compared to a full solar flare, but there could be millions of them happening every second, collectively dumping enough heat into the corona to explain its incredible temperature. The evidence for this magnetic violence is visible in stunning solar footage. Giant, arching structures called prominences, loops of superheated plasma, trace the lines of the magnetic field, soaring hundreds of thousands of kilometers into space. They are held aloft not by fire but by invisible magnetic force, and when you see the corona during a total solar eclipse, that beautiful, pearly white halo is not just reflected light, it is the glow of that million-degree plasma itself. Solving this mystery is not just an academic exercise, it helps us understand space weather that can disrupt satellites and power grids on Earth, all driven by the enigmatic furnace of our star's outer atmosphere. Jupiter's most famous feature is slowly fading before our eyes. For over 350 years, astronomers have observed the Great Red Spot, a colossal, swirling storm in the planet's southern hemisphere. This is not a temporary weather pattern but a permanent atmospheric fixture, an anticyclone so vast that for centuries it could comfortably swallow 3 Earths side by side. Its crimson clouds, likely colored by complex chemicals like sulfur and phosphorus churned up from deep below, spin counter-clockwise at wind speeds exceeding 400 kilometers per hour, trapped between opposing jet streams. Yet time-lapse images from Earth-based telescopes and visiting spacecraft like Voyager and Juno tell a sobering story. The storm is shrinking and it is changing shape. From a robust oval, it has become more circular and its size has diminished dramatically. By the latest measurements, it is now only about as wide as a single Earth. The question of what fuels such a persistent tempest is linked to the mystery of its decline. Unlike hurricanes on Earth, which draw energy from warm ocean water and quickly dissipate over land, the Great Red Spot has no land to cross. It is a self-sustaining engine fed by the absorption of smaller storms and the constant churn of Jupiter's deep, hot interior. Its longevity was once thought to be nearly infinite. But something is changing. The storm may be losing energy, starved of these smaller turbulent eddies that merge into it, or perhaps deeper shifts in Jupiter's internal heat or atmospheric currents are gradually robbing it of power. Some scientists speculate it could vanish within our lifetimes, becoming a smaller, perhaps paler spot before fading entirely. Others believe it might stabilize at its new, smaller size. Watching it shrink is like witnessing the slow closing of a cosmic era, a reminder that even the most majestic and seemingly eternal phenomena in our solar system are transient, subject to forces we are only beginning to understand. What other ancient wonders are we watching disappear without even realizing their final days are at hand? The fading fury of Jupiter's storm is a slow, majestic spectacle, but on a world far beyond our solar system, the weather is an exercise in pure, unrelenting violence. Exoplanet HD 189,733b presents a vision of hell so extreme it seems conjured from a fever dream. This gas giant, orbiting perilously close to its star just 63 light-years away, is tidally locked. One side bakes in perpetual, scorching daylight, while the other is plunged into eternal night. That temperature difference, a gradient of thousands of degrees, fuels winds that scream across the planet's surface at a staggering 7,000 kilometers per hour. To put that in perspective, these winds move at over 5 times the speed of sound here on Earth. They are supersonic hurricanes that never cease, a constant, deafening roar on a world with no air to carry sound. And within this superheated, supersonic maelstrom falls a rain unlike any other. The daytime side of HD 189,733b is so intensely hot, exceeding 1,000 degrees Celsius, that silicate particles in its upper atmosphere vaporize. These are the same minerals that form sand and quartz on our world. As these vaporized silicates are blown by the unimaginable winds toward the cooler night side, they condense. They do not form gentle clouds of water vapor, however. Instead, they crystallize directly into countless microscopic shards of glass. This is not a gentle, vertical drizzle. The planet's furious winds blast this razor-sharp precipitation sideways, scouring the atmosphere in a relentless, horizontal sandblaster of molten silica that solidifies as it flies. The result is a world of horrific beauty. From a distance, HD 189,733b appears a deep, serene azure blue, a color scientists believe comes from the scattering of light through those very silicate particles in its atmosphere. It is a cruel cosmic joke that such a tranquil color masks a reality of endless tempests and raining daggers. This planet stands as a stark reminder that the universe is not obligated to create comfortable, Earth-like environments. It can and does forge worlds where the very laws of physics conspire to create weather of breathtaking, lethal extravagance. That world of razor-sharp rain exists in a realm of extremes, but the most surprising water in our solar system is found in a place where it should be impossible. On Mercury, the closest planet to the Sun, daytime surface temperatures soar to 430 degrees Celsius, hot enough to melt lead. Yet at its poles, hidden in the deepest craters, there are vast reservoirs of water ice. This discovery shattered our basic assumptions about the inner solar system. How can ice survive so close to the inferno of our star? The answer lies in Mercury's unique geometry. The planet's axis has almost no tilt. Its poles are never angled toward the sun, meaning the rims of certain deep craters cast permanent, freezing shadows. Inside these sunless pits, temperatures can plummet to -170 degrees Celsius, creating natural deep freeze traps that have persisted for billions of years. But where did the ice come from? Mercury itself is too small and hot to have held onto water from its formation. The leading theory is a cosmic delivery service. Throughout the solar system's history, countless comets and water-rich asteroids have wandered inward. When one of these icy bodies slammed into Mercury, the tremendous impact would have vaporized much of its water, scattering it across the planet. In the sun-baked equatorial regions, that water vapor would have quickly been lost to space, but a tiny fraction, drifting on the thin atmosphere, would eventually migrate to the poles. There, in those permanently shadowed sanctuaries, it would freeze and adhere to the cold crater floors, accumulating layer upon layer over eons. This process is not unique to Mercury. We see similar shadowed ice at the Moon's poles, but finding it on Mercury, of all places, forces a profound rethink. It means water, that essential ingredient for life as we know it, is not a rare commodity confined to the outer, colder reaches of our system. It is a resilient traveler capable of surviving and even thriving in the most hostile environments, delivered by the chaotic ballet of comets and asteroids. The scorched, airless world next door to the Sun is not a dry desert but a silent, frozen archive, holding a record of the ancient water that shaped every rocky planet, including our own. Mercury's hidden ice reveals a universe full of unexpected resources, but the most shocking truth is that everything we can see, every star, every planet, every galaxy, is just a tiny fraction of what actually exists. All the light and matter that telescopes have ever captured accounts for a mere 5% of the cosmos. The other 95% is completely invisible to us, a realm of profound mystery known as dark matter and dark energy. This is not simply empty space, it is the dominant substance of reality, and we are only aware of it because of the ghostly influence it exerts on everything else. Dark matter was first suspected when astronomers studied the rotation of galaxies. The stars at the outer edges of spiral galaxies were moving far too quickly. According to the laws of gravity, based on the visible mass of stars and gas, these outer stars should have been flung out into the void. The fact that they are not means there must be an enormous amount of additional, unseen mass holding them in place, a massive halo of dark matter enveloping each galaxy like an invisible scaffold. We cannot see it because it does not interact with light at all. It neither emits nor reflects it. It only makes its presence known through its immense gravitational pull, the cosmic glue that holds the universe's largest structures together. Then there is dark energy, an even more baffling concept. In the late 1990s, astronomers made a discovery that turned cosmology on its head. They found that the expansion of the universe is not slowing down, as everyone expected from the aftermath of the Big Bang. It is accelerating. Something is actively pushing galaxies apart at an ever-increasing rate. That repulsive force acting against gravity on the grandest scales is what we call dark energy. It seems to be a property of empty space itself, a constant energy density that grows more powerful as the universe expands and creates more space. To visualize this, picture the universe as a loaf of raisin bread baking in an oven. The raisins are galaxies. In a normal loaf, the raisins would move apart as the dough rises, but the expansion would gradually slow as the bread sets. In our universe, the dough itself is not just rising, it is being infused with a mysterious leavening agent that makes it expand faster and faster, forcing the raisins apart at a pace that will one day tear the very structure of the loaf apart. We are left with a staggering conclusion. The universe we have built our science and stories upon is just the visible frosting on a cake whose ingredients we cannot identify. We are surrounded by and made from the cosmic minority, floating on a sea of invisible forces whose true nature remains one of the greatest puzzles in all of science. Saturn's majestic rings, those iconic bands of ice and dust, are a cosmic illusion of permanence. We gaze at them as ancient, timeless features, as much a part of Saturn as its golden hue. But groundbreaking evidence from the Cassini mission reveals a shocking truth. Saturn's rings are newcomers. They are likely only about 100 million years old, a mere blink in the 4.5 billion year history of the solar system. When dinosaurs ruled the Earth, Saturn may have been a bare, lonely giant. The rings formed long after the planet itself, perhaps from the catastrophic breakup of a wandering icy moon or a large comet that ventured too close and was shredded by Saturn's immense gravity. This youthfulness is matched by a startling fragility. Saturn's rings are not static, they are slowly, inexorably falling apart. Cassini's final, daring orbits between the planet and its rings uncovered a phenomenon called ring rain. Microscopic particles of ice, charged by sunlight and influenced by Saturn's magnetic field, are spiraling down into the planet's upper atmosphere in a constant, glittering drizzle. This rain is draining the rings of material at an astonishing rate. Scientists estimate that at this pace, the rings could vanish entirely in another 100 million to 300 million years. Picture the solar system before this spectacular ornament appeared. For most of its history, Saturn would have presented a smooth, unadorned face to the universe, a gas giant without its defining crown. The rings we see today are a temporary masterpiece, a fleeting alignment of cosmic circumstance that we are privileged to witness in their brief, glorious prime. Their inevitable decay reminds us that the solar system is not a static museum exhibit, but a dynamic stage where grand features are born, shine, and fade away, often within a timeline that fits inside the story of life on our own world. While Saturn's rings are a temporary visual spectacle, other cosmic objects carry a scent we can almost imagine. The European Space Agency's Rosetta mission performed an astonishing feat, not just landing on a comet but essentially smelling it. As the Rosetta spacecraft orbited Comet 67P, its instruments sampled the thin cloud of gas and dust escaping from the icy nucleus. The chemical analysis revealed a cocktail of molecules that would assault the human senses. The comet's atmosphere was laced with hydrogen sulfide, the compound that gives rotten eggs their infamous stench. It also contained pungent ammonia, which carries the sharp, acrid smell of horse urine or strong cleaning products. Mixed in were the sickly sweet aromas of formaldehyde and hydrogen cyanide, along with the scent of bitter almonds. This bizarre perfume tells a story far more important than its unpleasantness. These are all organic molecules, compounds built around carbon, the essential element for life. A comet is not just a dirty snowball, it is a frozen time capsule from the solar system's birth, and it is packed with the raw chemical ingredients that, given the right conditions on a young planet like Earth, could have sparked the chain reactions leading to biology. Think of a comet as a cosmic delivery truck carrying a cargo of prebiotic materials across the solar system. When comets bombarded the early Earth, they did not just bring water, they brought this entire toolkit of smelly, toxic, but vitally important organic compounds. So the next time you catch a whiff of something foul, remember that the same fundamental chemistry exists on a world of ice and dust sailing through the silent void. A reminder that the building blocks of our existence are written in a language of odor, connecting the most alien corners of space to the most familiar, if unpleasant, experiences of life on our own planet. The universe's grand design is not a uniform tapestry of light. Woven between the brilliant threads of galaxy clusters are immense, dark patches of almost nothing. The most famous of these cosmic voids is the Boötes Void, a spherical region of space so staggeringly empty it has earned the nickname the Great Nothing. Stretching approximately 330 million light-years across, this void is a gaping hole in the cosmic web. If our Milky Way were at its center, we would have seen no other galaxies in our night sky until the 1960s. The scale is incomprehensible. To traverse this void at the speed of light would take 330 million years, a journey through a desolate, intergalactic desert. What makes the Boötes Void so perplexing is not just its size, but its shocking emptiness. In a region of space that should contain around 2,000 galaxies based on the average density of the universe, astronomers have found only 60. That means over 97% of the expected galaxies are simply missing. This presents a profound challenge to our models of cosmic structure. After the Big Bang, gravity should have pulled matter into a relatively even web with clusters, filaments, and voids, but voids this large and empty were not predicted. They are cosmic anomalies, regions where the initial seeds of structure were somehow absent or where galaxies never managed to form. Some theorists suggest the void might be the result of many smaller voids merging over eons, like soap bubbles combining into one giant bubble. Others propose even more exotic ideas, that it could be the imprint of an interaction with a parallel universe, though that remains highly speculative. For us, the void inspires a deep, primal unease. It is the ultimate emptiness, a reminder that the cosmos is not obligated to be filled with light and life. Most of it is cold, dark, and profoundly lonely. If you were on a planet inside the Boötes void, your entire sky would be an inky blackness punctuated by only a handful of faint, distant smudges. The concept of a neighbor would not exist. You would be truly alone, adrift in a sea of nothing so vast it defies the human need for connection, showing us that isolation can be built into the very architecture of reality. The profound emptiness of the cosmic void makes our own celestial neighborhood feel almost cozy, but the distances here hold a surprise of their own. The space between Earth and the Moon is far more vast than our intuition suggests. On average, our lunar companion orbits about 384,400 kilometers away. That number is so large it loses meaning. To truly grasp that emptiness, consider this: you could fit every other planet in our solar system in that gap, lined up side by side with thousands of kilometers to spare. Start with the diameters: Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune. When you add all their widths together, the total comes to just under 381,000 kilometers. That leaves over 3,000 kilometers of empty space on either end of the planetary train, a comfortable buffer. Picture the lineup. Closest to Earth, you would see tiny Mercury, then the cloudy sphere of Venus, followed by the red disk of Mars. Next would come the giants, the massive bulk of Jupiter with its swirling bands, then Saturn with its rings stretching wide, followed by the pale blue marbles of Uranus and Neptune. All of them would sit neatly within the orbit of our Moon, a string of worlds tucked into a cosmic pocket we perceive as a relatively short hop. This fact shatters our sense of scale. We look up and see the Moon as a distinct, separate world, and it is. But the gulf that separates us is not a narrow channel. It is an abyss capable of swallowing the entire pantheon of planets that share our Sun. It forces a humbling realization: the solar system is not a cluttered place. It is overwhelmingly, almost terrifyingly, empty. The planets are mere specks of matter separated by oceans of nothingness, and even our closest celestial partner is far more distant than the mind readily accepts. The vast emptiness separating our world from the Moon is a physical reality, but our own bodies carry a more personal, intimate surprise about the nature of space. In the microgravity environment of orbit, astronauts actually grow taller. Freed from the constant, crushing pull of Earth's gravity, the human spine experiences a profound release. On Earth, gravity compresses the stack of spongy disks between our vertebrae, squeezing them like soft cushions under a weight. In space, that weight vanishes. The disks expand, fluid moves into them, and the entire spinal column gently elongates. The result is a noticeable and sometimes uncomfortable increase in height. Astronauts can grow up to 3% taller, which for an average person means gaining around 5 centimeters or 2 inches, seemingly overnight. This sudden growth spurt is often accompanied by a strange bodily rebellion. Without gravity pulling fluids downward, bodily fluids redistribute evenly. Faces become puffy, legs thin out, and many astronauts experience a persistent stuffy nose, as if they have a permanent head cold, because the sinuses are congested with fluid that would normally drain. The body's internal map of itself even gets confused, leading to a phenomenon where an astronaut's own arm, floating unseen, can be misinterpreted by the brain as a foreign object drifting into their field of view, causing a moment of startled surprise. This temporary transformation, however, is just that, temporary. Upon return to Earth, gravity reasserts its familiar dominance. Within a few months, the spinal discs compress back down, the fluids settle, and the astronaut returns to their original height, often reporting a renewed sense of heaviness and a deep, bodily understanding of the force that literally shapes us every single day. It is a humbling reminder that our very form is not fixed, but is a dialogue with our environment, and that in the silent embrace of space, we become subtly, undeniably alien to ourselves. The silent transformation of an astronaut's body in space stands in stark contrast to the permanent mark we have left on another world. On the airless, still surface of the Moon, the boot prints pressed into the gray dust by the Apollo astronauts are not fading. They will remain crisply defined for millions of years to come. This is not a metaphor for legacy, but a literal, physical fact dictated by the Moon's utterly alien environment. Earth is a world of constant erasure. Wind scours, water flows, plants grow, and tectonic plates shift, relentlessly recycling our surface. The Moon possesses none of these forces. It has no atmosphere, and therefore no wind or rain to weather the regolith. It has no active geology, no volcanoes or quakes to reshape its plains. Its temperature swings are extreme, but without air or water to facilitate chemical weathering. The physical imprints in the dry, powdery soil are subject only to the incredibly slow process of micrometeorite bombardment. Tiny particles from space will, grain by grain, eventually sand down the sharp edges of those footprints, but this is a process that unfolds over geological timescales. The tracks of the lunar rover, the descent stage of the landers, the discarded experiment packages, and even the iconic flag, though likely bleached white by now from unfiltered solar radiation, all sit exactly where they were left in a state of near-perfect preservation. They form humanity's first and most remote archaeological site, a collection of artifacts on a world that does not forget. This creates a haunting duality. The footprints are a testament to a fleeting, brilliant moment of exploration, a human endeavor that lasted only a few days, yet they will outlast not just the people who made them, but potentially all of human civilization, all of our mountains, and even the continents we call home. They are a message cast into the future, waiting for whoever or whatever next looks upon that silent sea of tranquility, a permanent whisper that says, for one brief moment we were here. Our lasting footprints on the Moon speak to a quiet, solitary world, but the cosmos often prefers more chaotic and crowded families. Far beyond our solar system, there exists a planet that orbits not one but two suns. This is Kepler 16b, a world that turned science fiction into scientific fact, a real-life Tatooine from Star Wars. Discovered by NASA Kepler telescope, this planet is a gas giant, slightly smaller than Saturn, locked in a gravitational dance with a pair of stars. The two stars themselves are a mismatched couple. One is a smaller, cooler orange dwarf star, while its companion is a tiny, dim red dwarf. They orbit each other every 41 days, locked in a tight embrace, while the planet Kepler 16b circles them both in a wider 313-day orbit. The existence of a stable planet here is a marvel of celestial mechanics. For a world to form and survive in a binary system is incredibly difficult. The competing gravitational tugs from two stars can easily disrupt the swirling disk of gas and dust from which planets are born, scattering the material or preventing it from clumping together at all. Yet Kepler 16b proves it is possible, likely forming farther out in the system and migrating inward to its current orbit, a path that somehow remained stable amidst the stellar duet. Imagine standing on a hypothetical moon of this gas giant. Your sky would be dominated by two suns of different sizes and colors, casting complex, ever-shifting double shadows. Their light would blend into a strange, alien hue, and when they set, you would witness a true double sunset, one star dipping below the horizon followed by its companion, a daily spectacle of cosmic ballet that on Earth exists only in the realm of fantasy. This discovery did more than fulfill a pop culture prophecy. It flung open the door to a whole new category of planets. If a world can find stability orbiting two stars, then the potential for habitable worlds in such systems expands dramatically, suggesting that even in the most chaotic stellar neighborhoods, the universe finds a way to build new homes. The enduring stillness of our lunar artifacts exists within a galaxy that is itself in motion, on a trajectory of cosmic consequence. Our Milky Way is not an island drifting in solitude. It is part of a local group of galaxies, and it has a destined partner in a dance that has already begun. The Andromeda Galaxy, that faint, fuzzy smudge visible in our night sky, is not just a neighbor. It is a future companion, currently racing toward us at an astonishing 110 kilometers per second. In approximately 4.5 billion years, our two great spiral galaxies will meet and merge. This is not a prediction of doom, but a forecast of spectacular rebirth. The initial approach will be a slow-motion ballet spanning hundreds of millions of years. As the galaxies draw near, their mutual gravity will begin to warp their majestic spiral arms, stretching them into long, luminous streams of stars and gas. From a hypothetical viewpoint far outside the event, it would look like two glowing whirlpools of light gently spiraling toward one another, their structures dissolving into a brilliant, chaotic tangle. The most reassuring fact about this titanic collision is that it will be, for the stars themselves, a remarkably gentle affair. Space within galaxies is so overwhelmingly empty that direct star-to-star impacts are incredibly unlikely. The average distance between stars is so vast that they will simply pass by one another, like two swarms of bees flying through each other without a single insect touching. The real drama will play out in the galaxy's immense reservoirs of gas and dust. These clouds will slam together, compressing under the shock and triggering a fireworks display of epic proportions, a burst of new star formation so intense it is called a starburst. The sky from any surviving planetary system would transform over eons. The approaching Andromeda Galaxy would grow from a faint patch to a brilliant, sprawling disk that eventually fills the entire heavens. As the merger completes, the two galactic cores, each harboring a supermassive black hole, will also slowly spiral together, eventually merging into one. The final product, after another 2 billion years of settling, will not be a spiral galaxy like our current home. The violent gravitational interactions will have stirred and randomized the orbits of billions of stars, creating a new, featureless shape, a giant elliptical galaxy that astronomers have already named Milkomda. Our solar system will likely be flung into a much wider orbit within this new hybrid galaxy, but it will almost certainly survive the journey intact. This future merger reframes our place in the cosmos. We are not residents of a static, eternal city of stars, but of a dynamic structure with a past, a present, and a spectacularly collaborative future, proving that even the largest structures in the universe are engaged in an endless, graceful, and transformative dance. The galactic dance of the future is driven by stars, but not all stars fit the brilliant, fiery image we hold in our minds. At the dim, cold edge of stellar classification, there exist cosmic failures called brown dwarfs. These are objects caught in a perpetual identity crisis, too massive to be considered planets, yet not massive enough to ignite the sustained nuclear fusion of hydrogen in their cores that defines a true star. They form like stars from collapsing clouds of gas, but their internal fire is a fleeting, sputtering thing. After a brief, warm youth powered by the fusion of deuterium or lithium, they simply begin a long, slow fade into obscurity, cooling over billions of years into cosmic embers. The most astonishing example is WISE 0855, a solitary brown dwarf drifting just 7.4 light-years away. Its surface temperature hovers around a frosty -23 degrees Celsius. That is colder than a winter day in Siberia, and theoretically, if it possessed a solid surface, it would be cool enough for a human hand to touch without being incinerated. Contrast that with our Sun, whose visible surface is a searing 5,500 degrees. and you begin to grasp the incredible diversity hidden within the category we simply call stars. WISE 0855 is so cold that its atmosphere is believed to contain clouds of water ice or even ammonia, weather patterns more akin to a gas giant like Jupiter than any sun. This redefines what a star can be. Our sun is a raging nuclear furnace, but a brown dwarf is a lukewarm, fading giant, a testament to the fine line between a world that lights up the cosmos and one that merely simmers in the dark. It reveals that the universe creates not just successes, but also quiet, half-formed things, objects that linger in the twilight between star and planet, holding secrets about the blurred boundaries of cosmic formation. The cold, fading embers of a brown dwarf could not be more different from the geometric perfection found swirling at the top of another gas giant. Saturn's North Pole is not crowned by a typical chaotic storm. Instead, it holds a shape so precise it looks engineered, a colossal hexagon etched into the planet's atmosphere. This is not a solid structure, but a six-sided jet stream, a wave of wind racing around the pole at over 320 kilometers per hour, with each side longer than the diameter of Earth. It is a planetary scale puzzle that has endured for decades, first glimpsed by the Voyager probes in the 1980s and studied in stunning detail by Cassini. The sheer persistence of this geometric cloud pattern defies our expectations of fluid dynamics, where we typically see spirals, ovals, or chaotic turbulence, not clean, straight-sided polygons in a whirling storm. How does a fluid atmosphere on a spinning sphere, no less, organize itself into a near-perfect hexagon and maintain that shape for at least 40 years and likely much longer? The leading explanation points to an elegant experiment you can try at home. Fill a round bowl with water, place it on a spinning turntable, and slowly increase the rotation speed. The water will eventually form stable, standing waves, and at certain speeds, those waves will have 3, 4, 5, or 6 sides. This is a laboratory demonstration of how fluids under shear, the difference in speed between layers, can self-organize into geometric patterns. Scientists believe a similar process is happening deep within Saturn's atmosphere. A fast-moving eastward jet at the North Pole creates a steep velocity gradient with the slower-moving air around it. This shear generates a standing wave that happens to have 6 sides, a stable configuration locked in by the planet's rotation and internal dynamics. The hexagon acts like a towering atmospheric wall, confining weather systems within it. From above, it appears as a honey-colored band with smaller storms and eddies churning inside its boundaries, unable to escape. It is a breathtaking example of how simple physical laws operating on a planetary scale can produce artwork of staggering complexity and beauty, a natural geometric tattoo on the face of a giant, reminding us that order can emerge from the most turbulent and unlikely places. The geometric perfection of Saturn's hexagon is a slow, stately wonder, but the universe also creates objects that spin with such frantic energy they border on the impossible. The fastest spinning natural object we know of is a star, or rather, the crushed remnant of one, a pulsar designated pulsar J 1748-2446 AD. This neutron star completes more than 700 full rotations every single second. To grasp that speed, imagine the entire mass of our Sun, compressed into a sphere no wider than a city, spinning so fast that its equator is moving at nearly 1/4 the speed of light. The forces at play are almost beyond comprehension, a testament to the most violent physics in the cosmos. This dizzying spin is a direct inheritance from the star's death. A massive star lives its life as a vast, slowly rotating sphere. When it goes supernova, its outer layers are blasted into space, but its core collapses catastrophically inward. Just as an ice skater pulls in their arms to spin faster, this core obeys the law of conservation of angular momentum. As it shrinks from a sphere millions of kilometers across to one just 20 kilometers wide, its rotation accelerates exponentially, spinning up to hundreds of times per second in a final, furious pirouette. What makes this pulsar and others like it so detectable is the lighthouse effect. Neutron stars possess unimaginably powerful magnetic fields, trillions of times stronger than Earth. These fields channel beams of intense radiation, usually radio waves, out from the star's magnetic poles. If these poles are misaligned with the star's rotation axis, the beams sweep through space like the beam from a cosmic lighthouse. Every time that beam flashes across our line of sight from Earth, our telescopes detect a pulse of energy. For PSR J1748, that pulse arrives over 700 times a second, a rapid-fire, metronomic tick of unparalleled precision. This creates a paradox of perception where one of the most chaotic events in nature, a supernova, gives birth to an object that becomes one of the most reliable clocks in the universe. It spins so stable it rivals our best atomic timekeepers. This pulsar is a whirling dervish of pure physics, a remnant of stellar death spinning so fast it stretches the very fabric of space-time around it, proving that in the aftermath of cosmic chaos, order can emerge in the form of a perfect, relentless spin. That relentless spin of a pulsar is a testament to how rotation can warp reality, and the same fundamental force has sculpted our own world into a shape that is not what it seems. Our Earth is not a perfect sphere. It is an oblate spheroid, meaning it bulges at the equator and is flattened at the poles, like a beach ball someone is gently squeezing from the top and bottom. This is the direct, physical consequence of our planet's rotation. As Earth spins, the material at the equator experiences a centrifugal force, a kind of outward push, that counteracts gravity just enough to cause a permanent bulge. The difference is measurable and significant. Earth's equatorial diameter is about 12,756 kilometers, while its polar diameter is roughly 12,714 kilometers. That is a difference of 42 kilometers, meaning if you stood at sea level on the equator, you would be over 20 kilometers farther from the planet's center than if you stood at the North Pole. This is not a trivial amount. It is greater than the height of Mount Everest multiplied by 2, but the story of Earth's true shape gets even more peculiar. The oblate spheroid is a smooth mathematical ideal. The actual shape of our planet, when measured with extreme precision by satellites, is far more lumpy and irregular. This real shape is called the geoid. Imagine the entire surface of the Earth were covered by a global ocean, perfectly calm and influenced only by gravity and rotation. The geoid is the shape that ocean surface would take. It would not be a smooth bulge, but a landscape of gentle hills and valleys, with some areas sitting dozens of meters higher or lower than the perfect ellipsoid. These undulations are caused by variations in the density of Earth's interior, the uneven distribution of mass from mountain ranges and ocean trenches, and the complex churn of our molten core. A satellite in orbit does not follow a perfectly smooth path. It dips and rises slightly as it passes over these regions of stronger or weaker gravity. So the next time you see a globe, remember it is a beautiful simplification. The true Earth is a dynamic, spinning, slightly squashed and subtly lumpy world, a shape not carved in stone but molded by the invisible interplay of rotation, gravity, and the hidden geology beneath our feet. Our planet's true, lumpy shape is a product of immense natural forces, but humanity has learned to sculpt reality on a far more delicate scale, creating temperatures that do not exist naturally anywhere in the cosmos. The coldest place in the entire universe is not in the dark void between galaxies, nor on some distant, frozen world. It is in a laboratory here on Earth. Using a technique called laser cooling, scientists have brought clouds of atoms to within a billionth of a degree above absolute zero, the theoretical point where all molecular motion stops. To understand how profound this achievement is, we must first grasp the scale of cold. The background temperature of deep space, the chill of the cosmic microwave background radiation, is about -270.45 degrees Celsius. That is only about 2.7 degrees above absolute zero. It is unimaginably cold, the natural baseline for the entire universe. Yet in labs at institutions like MIT and the University of Colorado, physicists have created conditions over 1 billion times colder than even that interstellar void. They achieve this by using carefully tuned lasers to act as a kind of optical molasses. Imagine atoms as tiny particles buzzing with thermal energy, moving rapidly in every direction. Scientists fire lasers from all sides, each photon of light delivering a precise, minuscule push against the atom's motion. When an atom moves toward a laser beam, the light's frequency appears shifted to the atom, allowing it to absorb the photon and slow down like running into a steady headwind. By surrounding the atoms with this laser cage, researchers can slow them to a near standstill, draining away their kinetic energy and thus their heat to within a hair's breadth of absolute zero. At these inconceivable temperatures, something magical happens. The atoms lose their individual identities and merge into a single, unified quantum state known as a Bose-Einstein condensate. In this bizarre form of matter, quantum effects, which normally govern only the tiny realm of particles, become visible on a macroscopic scale. The condensate behaves not as millions of separate atoms, but as one giant superatom, a single wave of matter. It can flow without friction, exhibiting properties like superconductivity and superfluidity that seem to defy classical physics. This is not just about breaking a record for cold. It is about creating an entirely new state of existence, a form of matter that the universe, in its vast natural processes, never bothers to make. While stars forge elements in nuclear furnaces and nebulae brew complex molecules, the ultimate cold requires not cosmic violence but exquisite human control. We have built a box where the rules of reality change, proving that our greatest discoveries are not always found by looking outward into the infinity of space, but sometimes by looking inward into the infinite possibilities contained within a single, almost motionless atom. From the deepest cold crafted by human hands to the dizzying spin of stellar corpses, these 25 glimpses reveal a cosmos that consistently defies expectation. We have wandered past worlds of diamond and glass, through voids of profound nothing, and into storms that rage for centuries. Each fact peels back a layer of the ordinary to expose the extraordinary reality beneath, proving that the universe is not just vast but fundamentally, beautifully strange. It operates on scales of size, time, and temperature that stretch our minds to their limits, yet it is also intimately connected to us, from the stardust in our bones to the cosmic chemistry that brews in distant clouds. This journey underscores a powerful truth. Reality is far more wondrous than we often allow ourselves to imagine in our day-to-day lives. We are not mere spectators in a static universe. We are active participants in a dynamic, evolving story, living on a fragile world adrift in a sea of mysteries both terrifying and magnificent. Our place is not at the center, but within the grand tapestry, and every new discovery, whether of a hexagonal storm or a fleeing moon, redefines our understanding of home. If this exploration has shifted your perspective, consider sharing that wonder. Let us know in the comments which fact reshaped your view of the cosmos. And if you want to continue unraveling the universe's secrets with us, please like this video and subscribe to the channel. The cosmos is waiting, and its next surprise is just a discovery away.